Okay, so we're going to take a look at another question from the electromagnetics topic. Here we are told a step-down transformer is connected to a 230 volt 50 Hz AC main supply. There are 1200 turns on the primary coil and 3 terminals on the secondary coil. When a 10 ohm resistor is connected between P and Q, the top 2 terminals on the secondary side, the current is 0.6 amps. When the same 10 ohm resistor is connected between Q and R, the second and third terminals, the current is 1 amp. We're told to find the potential difference between P and Q, find the potential difference between Q and R, and find the number of turns between P and Q and the number of turns between Q and R. Okay, so the way we're going to do this, we're going to draw a diagram. So we are assuming that this setup sort of looks like this. We have some transformer like so. It has some number of coils on the input side over here. This we're told is 230 volts and it's AC. So we are told the voltage primary is 230 volts. We are told the number of turns on the primary side is 1200. We're not told the current on the primary side. So current primary, this is unknown to us. Then we have a bunch of different terminal connections on the other side. So one here, then it continues to loop around. And then we have a third one down here. These are called P, Q, and R. So the top one is P, then this one is Q, then this one is R. We are not told how many turns there are in the secondary coil. We are told that if a resistor, a 10 ohm resistor is connected between the top two, so if a 10 ohm resistor is connected here, that we get a current of 0.6 amps. And if the 10 ohm resistor is instead connected down here, we get a current of 1 amp. So question A, find the potential difference between P and Q. Well, if P and Q are connected by the 10 ohm resistor, essentially we're going to ignore R and all of the turns outside of the gap between P and Q. We know that voltage is current times resistance. This implies the potential difference, the voltage across PQ, is going to be the current, which is 0.6 amps, times the resistance, which is 10. So the voltage across the PQ gap is going to be 6 volts. So this is going to be the potential difference between P and Q. For the second part, for part B, we're told to find the potential difference between Q and R. Again, we're going to connect Q and R, then we're going to ignore P and all the turns above Q. So now we're going to say V is I times R, and this tells us the voltage is the current, which is 1 amp in this case, multiplied by the resistance, which is 10. So this tells us the voltage between Q and R is going to be 10 volts. So these are pretty easy if you think about them the right way, right? Ignoring turns that are not connected, we can find these two voltages. Part C then asks us to find the turns between P and Q and the turns between Q and R. Well, we have everything we need at this point because we have the two possible secondary voltages. The first one for P and Q connection is 6. The second one for QR connection is 10. We have the input voltage, which is 230, number of turns on the primary side, which is 1200. So we know from our ideal transformer laws that Vp on Vs is equal to Np on Ns. We know that voltage primary is 230. We know that number of turns primary is 1200. So this gives us, and we're trying to find the number of turns secondary. So if we rearrange this, we get number of turns secondary is equal to number of turns primary times voltage secondary on voltage primary. We know 2 of these numbers. So this tells us that number of turns on the secondary side is 1200 on 230 multiplied by the secondary voltage. Now we have to evaluate this twice. We have to do it once for the connection between P and Q, once for the connection between Q and R. So for the PQ connection, we get the number of turns between P and Q is going to be 1200 on 230 times 6. This ends up being 31.3 ... So because this is not a whole number and we expect the number of turns to be a whole number, we will say 31 or 32. Pretty much both of these are acceptable in this case. You could also just round to 31. You could say, well, rounded to 2 decimal places, it's 31, but I'm going to say 31 or 32. And then we need to do this again for the connection between Q and R. We have QR, the number of turns between QR is 1200 on 230. Now this is multiplied by 10 as opposed to 6, and this comes out to be 52.17 ... So here we're going to say 52 or 53, right, depending on our choice of rounding. So this was a reasonably challenging question, but it was definitely manageable. It could be done with relative ease if you think about the problem in the right way, right? Ignoring parts of the coil that are not connected simplifies this problem greatly.